Welcome to everybody. I don't think we have everybody here yet, but there's Jerry. Welcome. And February 2nd meeting of the Cosmology Discussion Group. And Vladimir is going to give us a presentation about his latest paper. And hopefully we'll be able to have some discussions and questions so that we'll be able to understand more clearly. I think there's in past discussions, there's a lot of questions that people have. So hopefully we'll be able to get a clearer idea of what he's trying what his ideas are and what his theory is about, and we'll be able to appreciate it much better. So Vladimir, if you want to share your screen, I think we can get started.
Yes, I'm ready. One sec, let me see. Full screen. Okay, good. Okay, share
I don't have a
and request, send
all right.
request.
Okay, I've approved your request.
Yeah. Yeah.
Can you see? There we go. We see your presentation. I do anyway.
Today we will talk about four spatial dimension world universe cosmology. The most important part of talk today is four spatial dimension. That's why I will pay the most important issue is four spatial dimension. And why four spatial dimension?
That's exactly what I want you to talk about, because I think when you talk about four dimensions, I think that's really strange to a lot of people.
Let me tell you from the beginning. Big Mac model, they named their space-time as a four-dimensional space-time, but it is really not. It's a four-manifold space-time because the fourth dimension, it's imaginary. It's a mathematical trick. It is not dimension at all because it is ICT. It's imaginary unit. I don't know what does that mean, T, in this model, but they name it four-dimensional, absolutely wrong. As I told you, it's a four manifold. That's why I
Okay, now
insist that
let me interrupt you here. You're using the word manifold, and that's a mathematical term. Many people are probably not familiar with it.
yes, it's exactly what I'm talking about. That's why, orthodoxies, they mix form manifold. It's a mathematics, absolutely right. It's a mathematical model. It's a mathematical trick. Spatial dimension. It's a real dimension, the fourth real dimension. That's why from the very beginning, I want to show you exactly the difference between Big Bang model and my model.
Okay.
Do you have any questions about four manifold? It is mathematics, yes. And special relativity, general relativity, it is mathematical theories, and that's it, nothing special. There is no connection to
Okay, let
physics.
me just sort of comment a little bit here. This business that he's talking about, which he calls imaginary, okay, that comes out of special relativity. So this is Minkowski force space that came out of Einstein's theory of special relativity. Minkowski, who's a mathematician, proposed this force space model of mathematical model to describe Einstein's theory, and it has this imaginary time parameter. Okay, and it's referred to as a four-dimensional space-time. So that's what he's talking. I'm not sure this helps you to understand what he's talking about, but the origin of all this comes out of special relativity. That's the point I want.
But I might add, if I may, that system works for pre-relativistic physics as well, because if you take the wave equation, 1 over, sorry, the second partial differential with respect to time is equal to 1 over c squared, the partial differential with respect to distance. So if you take, instead of taking x, y, z, if you take x1, x2, x3, and x4, x1 is x, x2 is y, x3 is z, x4 is ICT. Well, then you get that classical equation.
Yeah, that ICT is the imaginary part that
Yes,
Vladimir mentioned.
there is no connection to physics at
Okay.
all. Guys, it's a mathematical theory without any real connection to the real world. And even time in their model, I don't know. Look, when I saw their definition, time is this axis, imaginary axis in our theory. Can you believe it?
Okay.
Definition through the axis, imaginary axis. I don't understand. I will give you the time, I will give you all the definitions, and it will be the real four spatial dimension. That's why it's be prepared that it's a totally different story. It's not mathematics, it is physics.
Okay, go ahead.
Okay, let's start. But what is important here, thank you so much for this very principal question you ask, your comment. It's very important because it's special relativity, general relativity, with all this vacuum, with all this stuff, it's inflation. I will talk later. It's nothing to deal with physics. It's mathematical tricks. That's it. Let's continue. Fundamental issues in cosmology. It is well known that any theory is based on certain hypotheses. World Universe Cosmology and Big Bang model are principally different models with fundamentally different hypotheses. Initial conditions. Big Bang model proposes an initial singularity with infinite energy density of the total matter of the universe, which was created from an absolutely nothing. The need for the universe to begin at t equals 0, avoiding a temporal singularity, extremely rapid expansion of space-time inflation. There is no center of expansion in the 3D universe. Where is it? Nobody told me. WC suggests a fluctuations in the eternal universe that created a fourth spatial dimension nucleus of the world with an extrapolated radius equal to a basic size unit about 10 to the minus 14 meters. The world is a hypersphere of the nucleus and had a finite extrapolated energy density about 10,000 times less than nuclear density. The nucleus expands in its fourth spatial dimension at a speed c, a gravitodynamic constant that is identical to the electrodynamic constant c in Maxwell equations, resulting in the even stretching of the hypersphere world. There is no need for the dark energy. Bunch of observable world. Big Bang model assumes an almost infinite, homogeneous, and isotropic universe around the initial singularity with the age 13.787 billion years. The observable universe is a spherical region of the universe consisting of all matter that can be observed from the Earth with a diameter of 93 billion light years. One more time, I don't understand this observable universe, 93 billion light years, because there is no even light coming from this area. How do we know it? It's a new mathematical trick of inflation theory. They stopped at 93 billion light years the diameter, and they didn't even tell what is going on behind this diameter. What? Maybe it is infinite universe, maybe not. No any information about this border between this diameter and the universe. Let me ask you the question. How we can name this area observable if we cannot observe it experimentally? I don't believe it. I don't understand it. It's all available matter, maybe, but it's not observable because we can observe only 13.7887. That's it, simple like this. WC describes the finite boundless world that is the hypersphere of four-dimensional nucleus with a three-dimensional surface volume 2 pi squared r cubed. The absolute age of the world, observable world, I will stress this word, is 14.227 billion years. Observable world is a 3D Hubble bubble with the radius 14.226 billion light years. This is our three-dimensional observable world. The volume of observable world 4 pi r cubed over 3, as we all of us know the geometry. And the total volume is 2 pi r cubed. It says that it will be multi-world without connection to each other, without touching each other. It is a virtual quilt of various main luminous superclusters. The ratio of the hypersphere to this observable world is equal to pi. It means that in the hypersphere world could exist three separate parallel worlds with the same laws of physics because all points of the hypersphere are equivalent and there are no preferred centers in it. We will talk about these parallel worlds a little bit later. Cosmic medium of observable world. Big Bang model often implies a vacuum state in the universe. Not open. There is existence of special relativity, general relativity, only for vacuum state. Forget about everything else. That's why vacuum, in 1905, as you know, luminiferous ether was canceled, rejected. There is nothing. There is only vacuum. WC proposes that the cosmic medium, which is both homogeneous and isotropic, while the distribution of macro objects is spatially inhomogeneous, anisotropic, and temporally not simultaneous. Cosmic medium consists of protons, electrons, photons, neutrinos, and universe-created particles previously referred to as dark matter particles. The rejection of the luminiferous ether in 1905 was a critical moment for classical physics. However, cosmic medium proposed by WC could be considered a revival of this concept, acting as a savior for classical physics. Let me tell you my opinion. In 1905, 120 years, this special relativity and then general relativity, they stopped development of classical physics. They threw away the most important part of classical physics, cosmic medium. Conservation laws. Big Bang model does not explicitly emphasize the creation and conservation of angular momentum in its foundation principles. WC stands out as the only cosmological model that provides a mechanism for angular momentum creation and is consistent with the fundamental law of its conservation. Formation. Big Bang model. Macro objects form from the bottom extrasolar system up to galaxies and superclusters. WC. Macro objects form from the top superclusters down to galaxies to an extrasolar system due to an explosive volcanic rotational fission of superclusters of spinning cores made up of UC particles, which were created by the universe during the dark invisible epoch for 0.44 billion years. The formation of galaxies and extrasolar system is not a process that concluded ages ago. Instead, it is ongoing. In conclusion, WC presents a radically different approach to understanding observable world compared to Big Bang model, challenging long-held assumptions and offering new perspectives on the fundamental nature of cosmology and classical physics. The hypotheses of Big Bang model are mathematical, while those of WC are more physical in nature. Both models may seem incredible, but there is a key difference. Big Bang model fails to explain many of the experimental results observed by contemporary astronomy. WC does.
That's an important point.
Yes, sir. I want to continue. If you have one question, I'm ready to answer, but because I will answer all your questions during my talk. Believe me. Can I continue?
Okay. Go ahead, no questions.
Why four spatial dimension observable world? First, WC introduced the concept of the hypersphere world to address the absence of the center of expansion in 3D universe associated with initial singularity. In frames of WC, the center of expansion resides in the center of the 14 nucleus. Second, the expansion of the nucleus causes the stretching of its surface, which constitutes the hypersphere world. There is no need for dark energy. Dark energy still everybody doesn't know at all anything about. There are no even speculations. What does it mean, dark energy? And this is a main player in the Big Bang model. We don't need it in this four spatial dimension observable world. Creation of matter is a direct consequence of the nucleus expansion in the fourth spatial dimension. Creation of UC particles occurs homogeneously in all points of the hypersphere world. If we have a creation, and we must have a creation because we don't have all the matter of the universe from the very beginning, then if we want to exist ourselves, we must have some matter from outside, from some places. That's why expansion, it is not because of some mathematical trick, because of redshift. No, it is the main point of this model because without expansion, there is no creation of matter. There is nothing to talk about in our observable world. Overdoing and Weston postulated that metrics which do not depend on X4, four spatial dimension, I stressed it, can give rise only to induced matter composed of massless photons. This is in the case of the Big Bang model. It's not only massless photons, it's neutrinos, all of them massless. We will talk about it a little bit later. While those which depend on X4 give back equations of state for fluids composed of massive particles. This is the case of WC. WC supplies this fluid, it's not fluid, it's cosmic medium, which consists of massive particles with rest energy, protons, electrons, photons, neutrinos, and UC particles. All of them particles, they have rest energy.
Okay, let me stop you here. This business of X4 is that's usually the imaginary time thing, right?
For Einstein, but for Wesson, it's a real spatial time. Okay, it's a real spatial. That's why I'm referring to Wesson. It happens he proposed his idea, his theory in 1983. Unfortunately, he passed away already. I'm so sorry because he was a great guy trying to convince people that there are particles in the cosmic medium. No, there is none. There is only vacuum. That's it. Something like this. Let's continue.
I beg your pardon, I missed that. Who was it in 1983 who proposed what you said?
Paul Wesson.
Paul Wesson.
Paul Wesson.
Paul Wesson, let me show you. Overdoing and Wesson, the Wesson proposed in 83, and Overdoing together with Wesson cited, quoted this quote, they put it in their paper in 96, 98, something like this, a little bit later. Yes, he tried to develop this, but nobody accepts as usually. Orthodoxies, they don't want to accept anything, including Professor Paul Wesson. He lived in Canada. He was a great guy. I learned his theory. I learned his papers, all of them. I'm in favor, with two hands in favor of his approach, and I will continue his approach in my model. This is exactly my point. What is important, even my first published paper was exactly continue of his theory. It was 10 years ago. The beginning of my publications was 5D space-time energy world. But today I will clarify everything after 10 years of my work on this model. I published already 38 papers, 10 years, it's a very long development or years. That's why, today I am concluding my model to put all the points, to give you all these definitions of all the physical notions we have in my model. Okay, let's continue. According to WC, all parameters of observable world depending on a dimensionless time-varying quantity Q, which is the ratio of radius R to a basic size unit A, are about 10 to the power 40, are a manifestation of observable world curvature in the fourth spatial dimension. The quantity Q, that is a measure of the size, dimensionless measure, and age of observable world is in fact the Dirac large number, his proposal in 1937. Leveraging the interconnectivity of primary cosmological parameters revealed by WC, we demonstrate that the gravitational parameter G experimental, which can be measured directly, enables the determination of all other cosmological parameters that are not directly measurable. Using G experimental, we calculate the radius of the curvature are as follows. From C experimental, we can calculate Q experimental, and then multiply this Q experimental on A, we can get this radius about 10 to the power 26 meters that equals to 14.226 billion light years. You see, we don't even speculate about it. We can, in frames of my model, we can even calculate this radius of curvature so huge that we cannot feel it, we cannot measure it, but it's exactly the radius of curvature of our world in the fourth spatial dimension. Cosmic medium composed of particles. There's the most important part, composed of particles. Intergalactic plasma, microwave background radiation, and far-infrared background radiation speak in favor of existence of cosmic medium. Intergalactic plasma parameters consisting of protons with mass mp and electrons with mass me can be found by investigations of fast radio bursts, which are millisecond duration radio signals originating from distant galaxies. These signals are dispersed according to precise physical law, and this dispersion is a key observable quantity that is in tandem with a redshift measurement can be used for physical investigations. The dispersion measure and redshift conducted by Kian et al. In 2016 provide the measurements of the cosmic density of ionized baryons in the intergalactic plasma medium that equals to 4.9 plus minus 1.3%, which is an excellent agreement with the predicted by WC in 2013 value of 4.8%. Let me tell you one more time. There is no maximum speed of light in our cosmic medium. Forget it. Fast radio bursts show that different radio waves, with wavelengths different, they have a different time coming to the same telescope. There is some delay between different component of these radio waves. There is no light of speed in vacuum. Forget about it. There is no special relativity. There is no general relativity. There, somebody stupid put in a Maxwell equation this definition, speed of light in vacuum. Absolutely wrong, because from the beginning in Maxwell equation, it was electrodynamic constant, and it was measured by great physicists before Maxwell equations. Maxwell only compared his calculated speed of radio waves, of wavelengths, of electromagnetic radiation, and he compared to speed of light measured by some other guy at the same time. And he found that they're close enough to each other. And that's it, what he found. But what is important, his theory based on electrodynamic constant C. It's a two different systems of reading of his equation, electric and magnetic. And there is a correlation between, and the coefficient of this correlation is C. It's not speed of light, it's electrodynamic constant. How many times I must repeat this fast radio burst that they prove there is no maximum speed of light? Forget about it. I'm very sorry for my emotions, because it is people, they don't know Maxwell equations. I don't know. They destroyed them by this definition. Light, speed, in vacuum. There is no vacuum, there is no light speed. There are only speed of electromagnetic waves with some additional parameters, and it's always less than this electrodynamic constant C. The existence of this maximum speed, it's not speed light. No, it is electrodynamic constant. You cannot get another constant. There is no another constant over this electrodynamic constant. That's why you're talking about maximum speed. It's not a speed, it's a electrodynamic constant, and you cannot even be close to it, because there is a medium, there is some interaction of any electromagnetic radiation with this cosmic medium, and you cannot measure it because it's less than maximum. One more time, maximum not of speed, it's a constant, electrodynamic constant of Maxwell equations. Let's continue. Origin of cosmic microwave background radiation. According, one second, I hope I didn't.
Okay, we got about 10 minutes.
Okay, we have 2 hours. Man, I'm ready to continue next session. I want today to be absolutely clear. I don't care about time. I want to convince at least you guys that there is some reason in my model why I'm talking about this one. That's why, don't worry, I will continue next session. Next, because intergalactic plasma is very important. Minimum energy of photons. It's massless in Big Bang model. Let me remind you. Analysis of the intergalactic plasma shows that the value of the lowest plasma frequency, nu minimum, equals to 4.5 hertz only. Photons with energy smaller than H nu minimum cannot propagate in the intergalactic plasma. Thus, H nu minimum is the smallest amount of energy a photon may possess, which equals to the value about 10 to the minus 14 electron volts. This value of minimum energy predicted by WC in 2013 is in a good agreement with the value obtained by Bonetti et al. In 2017. Compare apple to apple. You see predictions and there is experimental confirmation. They are very close to each other. It means there is no massless photons. There is a rest energy minimum. You cannot go lower. You cannot go to zero. I'm sorry. Origin of cosmic microwave background radiation, MBR. According to Big Bang model, the photons that existed at the time of photon decoupling, 380,000 years after the Big Bang, have been propagating ever since, though growing fainter and less energetic, since the expansion of space causes their wavelengths to increase over time. These photons are the same photons that we see in MBR now. But then, why is MBR a perfect black body? What is the mechanism of photons' wavelengths increasing over time and growing fainter and less energetic? I don't understand even any one word in these definitions. What is the increasing over time, wavelength, growing fainter, means losing energy where? According to WC, the concept of wavelengths is a classical, not quantum. Wavelength, in this view, is the property of an ensemble of quantum objects, such as photons and or electrons, all of which possess four momenta, but no individual wavelengths. In WC, the black body spectrum of MBR is due to a thermodynamic equilibrium of photons with the intergalactic plasma. It explains why MBR is a perfect black body radiation. The calculated value by WC in 2013 value 2725. I'm showing you these equations not because I want to confuse you. No, I want to show that all my mathematical calculations done exactly as it must be with the value up to 6 points after the comma, which is in excellent agreement with the measured value of 2725 by Fixen in 2009. Compare apple to apple. Yes, I've done these calculations a little bit later than it was measured. But what is the most important? Nobody in the world calculated this temperature. Nobody, never. There is no even one iteration of this temperature. There are some experimental results without any calculations, any comparison, theory with measured value. This is my model, what I've done in 2013. Far infrared background radiation. The cosmic far infrared background, which was announced in 1998, is a part of the cosmic infrared background with wavelengths near 100 microns, which is the peak power wavelengths of the black body radiation at temperature 29 K. We calculated the temperature of its peak, 28,955 Kelvin, that is in excellent agreement with experimentally measured value of 29 K. Nobody calculated this peak too, except my model. Meteorite neutrinos. It is established that there are three different types of neutrinos: electronic, muonic, thalonic, and their antiparticles. Neutrino oscillations imply that neutrinos have non-zero masses. Big Bang model 0. We analyzed this phenomena and calculated the values of their masses 0.31, 7.5, and 45 milli-electron volts, respectively, which are in a good agreement with the obtained experimental results in literature. This is my main point. Even neutrinos. Everybody knows about this, experimental results. And they don't care. It's all of these, experimental results are pollution for the Big Bang model. This is my point. Continue. I don't know how many minutes left, but I will start. Continue. Universe created particles. In our previous articles, we followed the standard paradigm dark matter that is not quite right for WC, in which all observable world consists of particles of ordinary matter, protons, electrons, photons, and neutrinos. On the other hand, there are particles created by the universe. You see particles of a new kind of universe created matter. In 2024, we introduce a new term, UC particles, which have following characteristics. UC fermions or bosons, rest energies, weak interaction, and self-annihilation, like Majorana the fermions. Ordinary particles are a byproduct of UC particle self-annihilation. It is easy to switch from dark, dim matter to universe-created UC matter. These particles are dark, optically invisible. When astronomers observe observable world with telescopes only, the contemporary astronomy allows us to observe observable world on wavelengths from radio waves up to gamma rays. Then they are not dark at all. The first known binary star system was Sinus X1 in 1971. That is typically the brightest persistent source of hard X-rays with energies up to 60 kiloelectron volts. In 2000, Minchin et al. Discovered binary galaxy system Virgo HI-21 with NGC 4254 galaxy, which has a 21 centimeter emission. You see, even there are some binary stars, binary galaxies with some extra radiation. It's not optical, but it's covering 18 orders of magnitude from tera electron volt up to 21 centimeter emission. It's a micro electron volts and rest energies. But all of them particles, they have rest energies, all of them.
Okay, we could pause here, I think. Could we pause here?
Of course. Maybe you will ask some questions.
Well, we got like
something
2
left, not much,
minutes.
but I have to continue. Yes, sir.
Okay, let's pause here and then go to the next section after the break. One of the couple of comments that I have to make here is that I think your presentation is a lot clearer than previous ones. And so I see a lot of things are clearer to me and a bit more specific. So I think that's good. So anybody else have any comments?
So much. It is exactly intent of my this today report or talk, because I want to clear everything, that you will ask all the questions, but I have all the definitions for all these physical parameters. I want to show you that everything sitting on good definitions and all of them experimentally confirmed. I provide you with all my calculations, and immediately I showed you these experimental results that confirm that in my theory, it doesn't matter. My equations of my theory, my calculations, it's very important because my model is based on experimentally measured parameters. And what is important, the Big Bang model, don't even discuss these effects. They don't want to know about them. How come? Physics is experimental science. You must confirm all your theoretical calculations based on experimental results. There is no any calculations. There is no any comparison. On the contrary, there is 93 billion light years, observable world, observable universe, they named it. And there is no way even to measure it, to see it. Can you believe it? It's a very good, proposal to have such observable world, and at the same time, there is no any instrument to look at this observable world of them.
Okay, well, that's good. I think you made that clear. That is a big, significant difference, and we're going to get stopped here in a few seconds.
Okay.
So
let's restart next session because I have something to tell later. Okay. Can you see?
And we're seeing your presentation is back up. Yes, and so we can
let's continue. Let's continue.
Okay,
particles.
Before we go on, does anybody have any comments or questions about what he said so far? Or are we just going to have? I'm sure Jerry's got some questions.
Yeah.
Maybe let's ask this question a little bit later. Maybe I will answer his question during the rest of my talk, because after we will finish my reading, then I'm ready to answer all your questions, guys, all of them. That's why, Jerry, please have your patience. It takes maybe 10 minutes, not more. And then you will ask whatever you want. Guys, let me finish because I don't want to split it and to tell, oh, I will answer this question later. No, it will not be later. It will be immediately. But please let me finish.
All right.
UV particles radiate gamma rays, which are emitted by nuclei due to the self-annihilation of UC particles with rest energies covering 18 orders of magnitude. You see, the most important is our standard radiation, electromagnetic radiation. It radiates by electrons or protons or some charged particles, no doubts about. No, don't. It doesn't matter. But what is important, the UC particles, they don't have charge. They cannot radiate electromagnetic radiation. But everybody knows that there is some annihilation, electron plus positron, supposedly one of the annihilations, we know about it. And there is some gamma radiation as the result of this annihilation. In UC particles, there is a self-annihilation. And we can see gamma rays with 18 orders of magnitude value from tera-electron volt to microelectron volts, as I told you before. WC proposes multi-component UC matter system consisting of two couples of co-annihilating UC particles, a heavy fermion UCF1, 1.3 tera-electron, and light spin zero boson Dirac. That is the dipole of Dirac's monopole with charge mu equals E over 2 alpha. E is an elementary charge, and alpha is dimensionless Rydberg constant. We will talk about later. And fermion UCF2, 9.6 gigaelectron volts, and a light spin zero boson L of 340 kiloelectron volts. That is a dipole of preons with electrical charge E over 3. Fermions UCF3, 3.7 kiloelectron volts, UC4, 0.2 electron volts, and boson Xion, 5.3 microelectron volts. The reason for this multi-component UC matter system was to explain the diversity of very high energy gamma ray sources in observable world. The diversity of UC matter cores of macro objects of ordinary observable world, superclusters, galaxies, and extrasolar system, which are fermion compact objects and UC matter reactors in WC. WC is based on two parameters only: dimensionless Rydberg constant alpha that has this equation, that is named the fine structure constant now, and R infinity is the Rydberg constant, and time varying quantity Q. That's it. There are only alpha and Q, two dimensionless parameters, one of them constant, another one time varying. We stress that the best theory is the one which is based on the minimum number of dimensionless parameters. It's a very important point of my model, because all the parameters that they depend on time will be measured together with quantity Q. If you have some constants, you will measure them with alpha. That's it. You don't need any more dimensionless parameters. No more. Two enough. And it's a minimum. You cannot go with less than two. There is no cosmic medium. There is nothing. In 1937, Nikola Tesla declared, all attempts to explain the workings of the universe without recognizing the existence of the ether and the indispensable function it plays in the phenomenon are futile and destined to oblivion. The concept of the cosmic medium plays a fundamental role in WC. WC, being a classical model, introduces classical notions only from the moment the first ensemble of particles emerged At the cosmological time, about 10 to the minus 18 seconds. Forget about 10 to the minus 32, 34 seconds. It's bullshit. Time, space, and gravitation are intrinsically linked to the impedance characterized by the Hubble parameter, the gravitomagnetic parameter, and the energy density of cosmic medium, respectively. Consequently, not time, space, and gravitation cannot be discussed independently of cosmic medium. Gravity under WC is not an interaction, but rather a manifestation of cosmic medium. This perspective aligns with the Lesarge's theory of gravitation, which in WC is based on UC particles referred to as xions. That's why the last one I showed you with microelectron volt rest energy xions, they are responsible for the gravitation according to Lesage theory. All physical laws are determined by cosmic medium, which is both homogeneous and isotropic. Indeed, the cosmic medium emerges as the cornerstone of classical physics, a savior of its principles. Let us not discard this profound concept with the tide of modernity. We must not throw the baby out with the bathwater. You see, cosmic medium, we rejected it, but all our physical laws depends on it. I don't want to ask the question. This gravitation law, the same 1 billion light years away. It's the same because all of them based on homogeneous and isotropic medium. It has the same properties, the same physical parameters in any place of observable world. That's why even the question, do we have a right to use the same fundamental laws? Yes, we can, because they depend on cosmic medium. And these macro objects, they are not homogeneous, they are not, isotropic. No, they can arise in any place and for cosmic medium. It's like a pollution of cosmic medium because like a liquid, and in this liquid we have particles, galaxies, extrasolar systems, and all this stuff. That's why it's very important. Conclusion: we don't need to doubt in our physical laws we have on our mother Earth. They are the same in all the world. Observable world, observable world. I will stress this definition, observable world. Physical meaning of the fourth spatial coordinate. According to Overdoing and Wesson, a fifth dimension might be associated with rest mass, while x4 equals gm/c squared. It is his conclusion. It is his. He named his model as space-time mass. I have changed it in his model, and you will see how I change it. In WC, there are the following parameters. In purpose, I put equations for G, gravitational parameter, and for E, or observable world, it's the overall energy of observable world. It has energy density, rho critical, and has observable world volume 4,5 r cubed over 3. I multiplied one by one. The fourth spatial coordinate is associated with the total energy of observable world. Take a look. X4 equals to this equation. As a result, R, and R is our model, C tau. This is a very important point. We don't have some imaginary fourth dimension. We have the four spatial coordinate, four spatial domain that equals to R, and it's C tau. There is no imaginary unit. There is tau, time, cosmological time. Let me show you what does it mean, cosmological time. As a conclusion, the gravitational parameter serves as a dimension transposing parameter. It's exactly a Western conclusion. The fourth spatial coordinate is associated with a cosmological time tau, which is defined as tau equals T0 multiplied on Q. Simple like this. There is no any other meaning. Cosmological time and T0 it's A over C. A is our size, minimum size, and C is a electrodynamic or gravitodynamic constant, and it's equals 10 to the minus 23 seconds. Q really is a dimensionless time and dimensionless area of our size of our world. If we will use our seconds, what we have right now, T0, you will have your tau in seconds. If you will put T0 any value, what you can put, it will be the same story, multiply on Q, and you will have the real cosmological time for now. You see what I mean? It's very important to tell you that we have dimensionless time and space of our world we live, observable world. And we can specify even these definitions, notions, seconds, meters, and all this stuff based on our T0A value, because radius equals the same story, A over Q, simple like this. It's a very important issue to tell you that our model, this WC, it's dimensionless model. You can saturate it with any measurable parameters. We like seconds. Okay, let's go with seconds. We like with meters, the same story with meters, but we can change any parameters, measurable parameters in our physics, and immediately we have a correlation with the all parameters of my model. You will replace T0 for new definition and A for new definition, simple like this. You see, it's a very important. Two parameters only, and there is no correlation with any fundamental cause, with any fundamental measurable parameters. It's our freedom to name this meters, seconds, whatever we want. And let's go with the last conclusion. For spatial dimension, World Universe Cosmology presents a fresh approach to understanding the observable world and the science of cosmology. It builds on the foundations of classical physics and has the potential to challenge core assumptions in both cosmology and classical physics. Rather than claiming to explain all existing cosmological data or presenting a fully developed theory, WC serves as a starting point for a new cosmology envisioned by Paul Dirac in 1937. While further refinement by the global physics community is essential, World Universe Cosmology's insights, combined with the groundbreaking discoveries of the GWST and the legacy of Dirac's ideas over 87 years, underscore the need for a paradigm shift in astronomy, cosmology, and classical physics. Fourth spatial dimensional World Universe Cosmology invites recognition and development. If you will start to develop your ideas in frames of my model, I will be more than happy, guys. I invite you not only recognition, but to develop any issues you have in your mind and try to think about your questions through the prism of my model. Thank you so much for your attention. Thank you very much for good questions. I bet you they will be very good. Please start your questioning, and I'm ready to answer any questions at once.
Okay, before you start, Jerry, I'd like to say I actually appreciate this, and I think it's a lot clearer than what you've talked about before. I think you're fine tuning what you're talking about and trying to make it more understandable to other people. And I think that's very good. I understand it better than I had before. I particularly like the business of Wesson, and because I didn't realize that connection before. and I did notice that when you were talking, there is some connection to the presentation that was yesterday. And when he was talking about the fine structure constant and dimensionless aspects of that. And so I'm not sure if other people understood that connection or not, but I begin to see that a little more clearly now. And I kind of tend to agree with you that this use of c as the speed of light is misleading, because what you're saying, it's really not really the speed of light. It's a constant and ought to be called something different. And I think calling it the speed of light is really misleading and confusing, and a source of a lot of problems. And of course, we also know that special relativity is one of the progenitors of a lot of problems in modern physics. So anyway, those are my comments. And I think another important aspect of it, just to finish up here, is that the JWST and the a lot of these things that they're discovering, they can't really explain, because their physics models really can't encompass a lot of the new phenomenon that they're coming across. And I think what's going to happen is they're just going to change their thinking in minor ways to accommodate these new things that they're finding. But I think there's really basically, we reached kind of this point now in astronomy and cosmology where it's becoming more and more difficult for them to use what they're calling their standard model to explain what they're seeing. Okay, that's my comments.
Let me make my comments to you, to your. Thank you so much for evaluation of my model. I tried to do my best to clarify as much as it possible. Hopefully, I've done my job good. But if you have any questions outside of what I'm talking about, I will be more than happy to answer. For me, the most important, your understanding and your questions after my talk. But let me tell you about, about the alpha. Alpha, yesterday it was a talk. I heard this talk. I know all this history of alpha, but he told that alpha was introduced by Sommerfeld later, when it was already quantum mechanics and all this stuff. It's not right. Unfortunately, he didn't read my paper. I showed that alpha can be calculated as a dimensionless Rydberg constant before quantum mechanics, before special relativity, before everything. This number alpha is from Rydberg formula, Rydberg equation. Multiply. He told that all these dimensions should be 1 by 1 divided. No, sometimes you must multiply. Rydberg constant is meter minus 1. If you will multiply on some number within meters, you will have dimensionless parameter. The alpha parameter could be calculated much earlier than quantum mechanics, Sommerfeld, and all this stuff. The second very important point about quantum mechanics. In quantum mechanics, all the notions came from classical physics, including speed, alpha, this equation, and all this stuff. It's a classical physics. My understanding, it's not right, because you cannot put space, time, and all these parameters inside of quantum mechanics. They don't exist. That's why even alpha, it doesn't exist. It exists in classical physics. It exists. I calculated. I found it. I've done this, very simple calculation based on experimental results. Experimental results, it's electrodynamic constant, Planck constant, or Rydberg constant, and ratio of mass electron to mass proton, that's it. All my calculations done based on 4 well-known experimental results, and immediately I found the expression for alpha. It's simple like this, and I showed you even in my report. It's 1/3 power of 2 r infinity. That's it. I can show you this equation. It's a very simple equations. It's very simple, but it's not from the sky. It's from a strong calculation based on experimentally measured results. Please stop talking about even alpha in quantum mechanics. You can use this parameter, you can use whatever you want. And he gave very good, by the way, history. It was very good, but it's obsolete. I mean, he showed that alpha from quantum mechanics. No, it was much earlier. Simple like this. And if you can use it in quantum mechanics, fine, but don't put attention. Planck constant. It was calculated, measured by Planck in 1903 because before special relativity, before quantum mechanics, before everything. And what was his approach? Statistical thermodynamics. That's it. No quantum mechanics, nothing. He found his equation based on statistical thermodynamics. And he found this, one more time, quantum mechanics, they use Ash, but Ash constant doesn't belong to them. It belongs to classical physics. You see, what is my main point right now? Quantum physics didn't generate any new definition, new notions. No, they use the same parameters as in the classical physics. And it's a very good quasi-classical approach. There is such bridge between classical physics and quantum physics. Quasi-classical approach, that's it. Simple like this. Even planetary model, the first one, was from sun and planets around, It's the development of the theory, but it's already over 100 years ago. At least let's recover them too. I mean, this quantum physics, and to tell guys, invent something new, have a new approach. Because you cannot use it. You cannot use Schrodinger equation. You cannot use all these parameters. You must show me why you want to use it. Invent something new. Invent something new for quantum physics too. I'm sorry, as usual, for my emotions, because I'm so happy to give you a talk today, and I hope that at least for you, I will clarify the value of classical physics and what's happened with special relativity. We stopped classical physics for 120 years. We stopped development of it, and I pretend that I continue classical physics. My point is not before 1905. The last experimental results I used in my theory is Planck's statistical thermodynamics. That's it. He calculated this Planck constant in 1903. Simple like this. All the rest parameters will be much earlier in 19th century. That's why WC, it's a continuation of classical physics, which was stopped by special relativity, general relativity, in 1905. Sorry.
You're muted, Jerry.
Yeah, very good, very good. I actually like the summary, and um, I, I'm not sure whether other people are getting the picture. I've been feeling for a long time that this special relativity and Einstein kind of mess things up. That's not really what mainstream wants to hear. They don't want to think about that maybe Einstein messed things up, and that relativity kind of sent physics in the wrong direction. But the more I studied this over the years, the more I'm kind of convinced of that, because they had to change Maxwell's electromagnetic theory. And so what happens is there's a lot of confusion and electromagnetic theory created by the attempts to reformulate Maxwell's theory once the ether had been gotten rid of. So they had to do some gymnastics to save Maxwell's equations, although there's no ether anymore. And so, and so a lot of these changes that have to come into place then, made other things messed up and other confusions. And quantum mechanics is another area where, the confusion kind of starts multiplying. And now are in a situation where a lot of this stuff doesn't really fit together anymore. The electromagnetic theory doesn't fit with, these other. I think you made that case. I think you made that case that going back to classical physics and developing a cosmological model based on classical physics is a good idea because there's so much confusion going on in quantum mechanics, and you bring in special relativity, and trying to make a cosmology out of special relativity, I think is a fruitless exercise, but they're committed to
it. They're not even committed. It's a religion right now. They don't want to lose it.
I
They
know that
cannot.
right, exactly. That's true. And that's why, if you criticize special relativity, I mean, it's like pushing a hot button. You don't really get a rational conversation as a result.
It seems to me, yes, it's not irrational because there is no vacuum, there is no maximum speed of light, and all these definitions mathematical. There is no
uh,
physics behind special relativity and general relativity. None.
okay.
And
I did want to, you mentioned a couple of things that we talked about last week, where Jerry had talked about this maximum velocity limit. And I sent out a link to Einstein's 1907 paper, and he briefly mentions that in his paper. So I sent that to you, Jerry. You might want to look for that. Where Einstein, that's where it comes from, but he doesn't really explain anything. He just says that going faster than c is not in his principles of his theory. Okay. And so that's one of the references that you can look to where this idea comes from.
I might bring up a point. Apparently, Vlad does not accept special relativity, but on several occasions he mentions the four momenta, which for many of us, we associate that whole idea with special relativity. So your idea of the four momenta is not, I see you shaking your head.
Okay, let's stop here. There's some kind of noise on your audio.
yes, very noisy. But I
Oh,
understood
it started to rain here. It started to rain, and I have a corrugated roof, so I'll come
My
later.
goodness.
I'll come later.
Yeah, we
Okay.
couldn't really hear you.
Let me answer his question. It's a very good question. First of all, there is no any connection between four momenta and Lorentz transformation. It's a totally different story. There is in common only four. That's it. Simple as this. Very sorry, because these equations for four momenta, take a look without Lorentz, you will see what is the total momenta. It's standard three-dimensional momenta plus mc squared. It is the momenta in a fourth dimension. That's it. No correlation, no connection. Forget about it. Lorentz, I do like him very much. He was a classical physics. It's a very good transformation, but no connection to quantum physics. And you can see this equation in any textbook. No connection to Lorentz. Forget about it.
I had a few questions and comments that I wrote in the chat if anyone is interested. Well, thank you for your presentation, Vladimir.
Okay.
Well, one question is how to define dimension. I mean, it's commonly thought that height, depth, and width like in our practical everyday world, the dimensions of objects. And then there's also more of a theoretical view of, areas of motion. Well, I don't know if I have terminology right, but like forwards and reverse and up and down and side to side and such. However, though, why is a fourth dimension, spatial dimension, necessary?
Sorry, your question is why fourth dimensional, spatial dimension?
Of the four-dimensional nucleus that spontaneously created everything. Why four dimensions?
Well, the main point of the whole talk was about fourth dimension. And I can come back to the same slides what I had before, and it was at least 6 or 7 points why we have to use four dimension.
Well, I read it all, and there was a lot of complex math that
There's no complex math.
I didn't understand, though. I don't know in practical terms why a fourth dimension is necessary. That's I just personally don't understand.
The fourth dimension, first of all, and it was my first point of the presentation. You don't have center of expansion in our 3D world. And it's well known, it's obvious. If you don't have something in 3D, you have to go to 4D dimensional space. Why? Because then you will find your center of expansion. Because they are talking about expansion, but there is no center of expansion. What kind of expansion they are talking about? They don't understand even this word, expansion.
How to observe the four dimensions, and why wouldn't that four-dimensional nucleus, as it spontaneously creates physical phenomena to create the universe, why isn't that the center of the universe?
Because according to my model, I showed you that the radius of these four-dimensional, space-dimensional core nucleus of the world is expanding, and there is a stretching of the surface of this four-dimensional nucleus. We live in the surface, on the surface of this four-dimensional nucleus. Simple like this. We cannot measure, we cannot watch, we cannot observe this nucleus. We cannot. We are 3D, you and me and all of us, 3D objects. We can see only three-dimensional space. And fourth-dimensional space, we must use, and I gave you 7 points why we must use. And next, very important point. We have creation of the matter. In any 3D dimension area, sphere, suppose the Hubble bubble you have, and you have your matter coming through the water, but then it will be saturation of this world only close to the border of this Hubble bubble. That's it. You cannot wait for some particles coming to us at the center of this Hubble bubble. And only if you have your fourth dimension, you have a continuously creating matter and homogeneously in all points at the same time. Even now, you're sitting in your lab or in your home, you have all this penetration of all these particles from this nucleus to your body. And all of us have the same number of particles, the same homogeneous saturation of the world with a new matter, maybe only because of the fourth dimension, because there is no other choice. You see what I mean? You cannot create matter in 3D because then you will have some matter, additional matter, only at the border, and you don't have anything at the center of it. This is a very important point to understand. Expansion you must have of the fourth dimension to saturate, to create a new matter. And creation of new matter, it's not God that created at one point, like, in Big Bang model. It's a God. He created from nothing this, initial singularity. In my case, the model based on a continuously created matter, continuously. And there is only one way to saturate our world with this continuously coming matter, homogeneously in all points from the fourth dimension. And fourth dimension, you see, I put energy, the whole energy we got from the universe along this fourth dimension. Fourth dimension is the source of energy for our world, observable world.
Oh, what is your view of how the four-dimensional nucleus got there? Like, how did it enter existence? And was, but you had mentioned that the universe is finite yet bounded. Was the four-dimensional nucleus finite yet bounded, or was it there? At what point did the universe become boundless?
Well, it's not universe. You see, universe, Big Bang model, forget about it. In my case, it's totally different. Universe, it's totally different. Our world, our observable world, the world is boundless because you have your sphere. So I will give you the analogy. You have your three-dimensional sphere, and you have surface of it. How you can measure any parameters, the thickness of this surface? How? Surface is surface. There is no dimension along the radius. The same story with the fourth dimension. We are the surface of this nucleus, four-dimensional nucleus. I mean our world, observable world. We are on the surface. There is no nucleus. There is no surface of it. There is none. Not you, not me, nobody. This is the point. We cannot exist without this nucleus because our world is the sphere, hypersphere of this nucleus. And we live in this hypersphere.
Okay.
All right, we don't have that. We only have a few minutes. I know that you're confused, Jerry, and I don't think asking Vladimir this question over and over again is going to help.
I asked him quite a few questions. I wouldn't say I'm confused. I just don't understand.
Well, that's my point. Yes. Okay, I'll say you don't understand.
Well,
And
I don't see adequate proof for anything. You know,
it's a mathematical construct, and I think that's
math is supposed to be based on physical phenomenon, though. Which you should be able to explain the math.
all right. Well, so what we have here is a philosophical
well, maybe philosophy
discussion.
connected with science, though. I mean,
Well, what?
The point of inquiry.
All right, we only have like less than a minute to go here, so perhaps we can talk about this after the break.
And so let's continue after the break because I don't want to stop questioning, answering. Let's have additional session for questions.
I want to point out that Vladimir, I think, has explained it. The problem is you don't understand the terminology. Okay, the terminology is confusing because you need to understand this mathematics.
What terminology are you missing?
Huh?
What terminology you don't understand that you think would bring you to understand? What
do you know what he means when he talks about the surfaces stretching?
Well, it sounds quite mystical, similar to the Big Bang to me.
Well, yes, that's because the terminology isn't very clear if you don't really understand what he's talking about.
Well, why assume that there is stretching?
Okay, we kind of got stopped in the middle of this. I see there are some contradictions in what's being said, and it's kind of confusing. Because what Vladimir is saying is his model is based on experimental evidence, and then but its fundamental basis behind it is really a mathematical concept of four dimensions, and four dimensions is not something that we can access. Okay, and I understand that there's a philosophical issue and a problem in understanding this. And my only comment that I can make at this point is that you have to view the four-dimensional part as a model that is used to explain what he calls the observable world. So we are living in the observable world, which is a three-dimensional part of a four-dimensional spatial manifold. Okay, and then what he does is he's explaining what we observe in our three-dimensional observable world by a something that's happening, an expansion. Our three-dimensional world it appears to us to be expanding because of it's moving and it's expanding in the four-dimensional world. The four-dimensional manifold is, so three-dimensional space is embedded in a four-dimensional manifold, but the fourth dimension is inaccessible to us. We
I don't
can't.
know it exists.
Well, see, now you're asking a philosophical question.
Well, it's a scientific question too.
No, it's not a scientific question. It's a philosophical
Well, it's a
question.
valid question.
It only becomes a scientific question when you're asked to, what he does, he's saying, I can explain phenomenon in the observable world based on this assumption that there's a four-dimensional manifold. That's when it becomes scientific.
I don't see how that helps.
Hold on, to ask the question about where this four-dimensional world came from and why would it exist is a philosophical problem, not a scientific problem.
It is the four-dimensional world observable?
No, it's not. That's the whole point.
Why talk about it? Why assume its existence?
It's necessary to explain the observable world. So,
well,
You're absolutely right.
Is there even a single point in Vlad's talk? Thank you, Vlad, for your talk. Where the fourth dimension was used. You know, I don't recall a single instance where the idea of a fourth dimension being even used in any of the calculations that he presented. I may have just missed it.
You're absolutely right. Observable world is three-dimensional. All the calculations I've done according to standard classical physics in three-dimensional space. I will tell you where it is. It is in time varying gravitational constant, in time varying all the parameters. This is the main point. They depend on Q. And Q, by the way, do you know philosophical, by the way, this concept of Mach, that our local physics must depend on the whole universe. It says exact realization in my model. All the physics, we're talking with you, it's a three-dimensional physics and so on and so on. But what is the most important? Where we can have feeling of this fourth dimension. These parameters all time varying. And time is cosmological time. And I gave you the way how to calculate cosmological time. What does it mean? And I gave you the calculation of the radius of this curvature. I gave the calculation. Of course, we don't know about fourth dimension. We cannot measure it.
The radius is expanding, and if so,
Sorry?
at what velocity?
I'm sorry?
Is
I misunderstood
the
you.
expanding of the hypersphere radius expanding, and if so, at what velocity?
Velocity equals to gravitodynamic constant C, that's to electrodynamic constant C. There is no speed of light. Forget about it, guys.
Well,
There is a fundamental
was
philosophical
the
question, though,
expanding.
which does impinge upon the science of all this. I think. I mean, we all have our own disparate ways of looking at these things, and I think we all agree on the principles that you've enunciated and Harry has repeated. You know, about criticizing classic, you know, the modern physics and so on. But there is a fundamental question which I think must be asked of any model. You know, a devil's advocate might say, look, you've shown, Vladimir, that you can derive all these constants to many places of decimals, and you know, it's constant with these results and so on. But does that mean that it's true? I mean, it might be merely like the Ptolemaic system, which actually initially was more accurate than the Copernican system in predicting events. It was just a model which was like a curve-fitting process. Inherent, if you permit me to say, in your system are a lot of things that cannot be verified, like 400,000 years after the beginning of the universe, such and such things happened with regard to and so on. So I'm asking, you know, can one establish any real validity to this other than that it's a model which works?
Philosophical question, reality of model. From the very beginning, I put the first sentence. Any theory based on hypothesis. Even mathematics, you have two lines parallel because there is no cross of them. Or you have the mathematics, they cross each other. That's why if you will not accept hypothesis, then you cannot develop any model. That's why you're asking philosophical questions, and it's at the basis of hypothesis of the model. And then it must be only logic, logic. There is no logic in Big Bang model at all, at all. Hypotheses, they are absolutely wrong. They are mathematical, not physical. That's why I can come back to my first, page of my talk and to show you what are the hypotheses of it. That's why even this hypersphere, this, the four-dimensional nucleus, it's hypothesis of the model. But what is important? Stretching of this surface, immediately you don't need dark energy. Nobody knows what does it mean dark energy. And 70% of our energy, of our observable world, inside of dark energy. Can you believe it? I don't. Validity of model depends on what are the first step of your hypothesis, and then please find the contradiction of my conclusions based on this hypothesis. Simple like this. Any theory, any mathematics, physics, all of them based on this hypothesis. And I started my talk today from differences, principal differences in hypothesis. Simple like this. That's
Okay,
why,
that's
guys, you're
appreciated, and
asking the
thank you very much
question.
for explaining that. But my own inclination is a bit like Newton's. I don't frame hypotheses. Hypotheses non fingo. I prefer to adopt the minimum of assumptions and adopt the most simple models possible. And I'm just saying that possibly is a criticism of your impressive work, which is giving very good results, but philosophically could be criticized on the basis that it's introducing a lot of hypothetical work.
Well, not real.
No,
Well,
no,
in a way, you
no.
could view it that way. Um, yeah, I understand this, and to say Jerry kind of says, well, where's your proof of this fourth dimension? Okay, and this is philosophical. What he's trying to say is he has a model, okay, that is an alternative to the current cosmological model. Okay, that's what I see it, and he's saying my alternative to the existing scientific dogma, which is what it is dogma. I have an alternative to the current existing dogma, and I think that you should take a look at this because it's based on observations and explains observations better than your current model does. I think that's what the essential point of it is. And of course, if you're a critic, you're going to go and say, well, this fourth dimensional hypothesis doesn't make any sense. I don't understand that. Well, it makes as much sense as the general relativity does based on special relativity, which makes no sense. Special relativity makes no sense. And then they base general relativity on a theory which makes no sense. So the whole thing's based on nonsense. So, but they don't want to accept that.
Maybe they don't even need to worry about this fourth dimension because Vlad himself says that he's not using it in any of his calculations. And so.
Oh, it's used in the calculations. The point is it's an hypothesis that allows him to explain the expansion of the universe.
Well, he just said that he didn't use it.
No, you misunderstood me. I told you. Their use of the fourth dimension is very simple. I have time varying parameters, gravitational, Hubble, and all this stuff. You cannot go with a constant gravitational constant. That's simple like this. That's why you misunderstood me. Even, the most important part of the model is you can use always the same physical laws, the Newton laws, or whatever it is, but take into account, consider the dependence of this constant in time. You are talking about 4.6 billion years ago when our Earth was born. It's okay. Or you're talking today, now. You must take into account the difference in these constant, they're not constant, they're time varying parameters. And this is only because of the fourth dimension. Q, parameter Q, I told you one of my conclusions was that all the parameters, a lot of them, I can show you at least 10 of them, depends on parameter Q, means immediately that it's a description of the fourth dimension. It's a validation of the fourth dimension, because without fourth dimension, you cannot explain the time varying with these parameters. You cannot.
I have a
Why?
quick question.
Yes.
As far as the four-dimensional nucleus goes, I mean, does it mean that our universe today is four spatial dimensions? And if so,
No.
why not five or more?
That's a philosophical question.
Maybe it's a philosophical proposal to suggest there's a fourth dimension in the first place. If you can't define it in scientific terms,
You're creating red herrings, Jerry. I mean, this is just a philosophical red herring that you're creating.
Okay.
It's not really what.
Didn't you say you can't prove the fourth dimension or you can't observe it? Did you say that?
So now we've reached a point where we're censoring questions.
No. He's asking
that's
questions that aren't relevant to what we're talking about.
Of what's going on here.
No. You don't understand.
Let the gentleman Vladimir answer the question.
Hold on.
Rather than
His question is, if there's a fourth dimension, why not a fifth dimension? Why not a sixth dimension? That's not what his model is talking about. It's not his model. So
okay, so you're speaking.
How does he answer that question? Go ahead, answer the question. Why not 5 or 6 dimensions, Vladimir?
I'm very happy that Harry, he can answer your question, because it means how deep he understood my model. Harry, thank you so much. You're the best listener and best thinking guys, and so on and so on. He's absolutely right. I'm so happy to start my work together with you in May. It will be 1 year of our very tight relationships. And only because of you, I started to clarify everything. And today, my main point was to do this talk for you personally, to clarify all the questions you asked me in May last year. Oh my God, how it was like a cold shower for me. You ask, what does it mean this? What does it mean that? You see how changed my even definitions, notions, because of your good questions you asked me during this time.
Okay,
thank you so much, Gary.
Answer why there's not a fifth dimension in your model.
There's no fifth and all this stuff. Forget it. We don't need them. Jerry, you can develop your new theory with 6 dimensions. By the way, we have this string theory. Do you know this string theory? It might be 12, 21 dimensions. And you are not happy with my 4 dimension. Go to them and you will enjoy this 21 dimension.
I personally prefer the 3, and even subtracting time from the equation. I mean,
all right, I'm gonna sort of step in here, and I think that Vladimir pointed this out. I don't know that it really resonated with people, but Vladimir is saying the fourth dimension is needed to explain why there's no center of the universe's expansion.
Yes.
Do you understand that? That's why there's a fourth dimension. Okay.
But it may appear to some people that by postulating this hypersphere, by definition, this, which is enlarging from its center, that there is a center. So it seems, some people might construe that as sort of contradictory.
Yes. But that contradiction exists in the Big Bang model too, I think. And they have a way of papering over that problem. So,
well, why don't we just get rid of all the contradictions?
Well, the problem, yeah, but it's a model. I mean, and it's a way of trying to explain the observations, and I think that's the point that you're missing. What he's trying to say is that this model is a way of trying to explain the observable universe, which is what we see and what we live in.
Well,
and,
I accept
and
that
such it's a model.
Making an effort which has a lot of merit. Okay, so I'm not disputing that at all. But if it's recognized that there is a contradiction there in this model and presentation, one would think, at least in my homework, if I find a contradiction about the first order of business is to find out why and what's going wrong here. And to remove the contradiction. And yet I'm hearing apparently that, well, it's okay to have contradictions.
Well, modern physics accepts contradictions. So anyway, that's another subject.
Yeah.
James, no, I'm tired already of this word. James,
let's let Vladimir answer this.
I'm so sorry. James, please formulate contradiction of my model. What is a contradiction? Formulate with a responsibility for each word. Please formulate your contradiction.
The hypersphere has a center, and you say the hypersphere is expanding.
No. That's not correct. There's your mistake. That was wrong, what you just said. The hypersphere is expanding. Wrong. No. It's the three-dimensional surface embedded in the four-dimensional hypersphere.
Yes. That's it. Simple like this. And you misunderstood this very simple point, James. I'm very sorry for you guys.
Well, then I have to say that
contradiction in your mind.
That your use of the term hypersphere is quite different from what I've read in physics literature and mathematical literature as to how the word hypersphere is used. And so you might want to look at that, because that could be a point of confusion, because there's a whole lot of people out there who are very qualified and well-trained, who the main point of a hypersphere, one of the points of definition of what a hypersphere is it has a center.
All right. That may be an issue. And maybe Vladimir.
The center is the center of the nucleus. If you will go to math, please take a look on all your papers, everything. Yes, hypersphere has a center in the fourth dimension, and it's coincide with the center of this nucleus. That's it, simple like this. I told you from the very beginning, where is the center of expansion? In the fourth dimension, coincides with the center of this nucleus. That's it, simple like this.
Well, okay, because we were talking about that there is no center. So,
no.
James,
no. Artificial contradiction. There's no center in the three-dimensional surface embedded in the four-dimensional hypersphere.
Well, if the first thing to enter existence if the first thing that ever existed was the four-dimensional spatial nucleus, and it spontaneously created everything that would surround it and expand outward, or whatever the terminology is, why wouldn't that be the center?
Now you're confusing the universe four-dimensionally with the observable universe, which is three-dimensional.
Okay.
And he's trying to make that clear. He's trying to make that clear, and I suspect that it's not clear, and maybe there's an issue there in clarity and emphasis, but he's defined a four-dimensional hypersphere universe. Maybe there's a problem with that terminology that's confusing people, there, and then embedded in that, there is the three-dimensional observable universe in which we exist and make our measurements and experience physical phenomenon.
Well, if the three dimensions is embedded within the fourth dimensions, why isn't it all four dimensions?
You have to ask a mathematician that one.
See, I
From
mentioned earlier
mathematical-
that I have
Oh.
no problem with this. I think the confusion may indeed be terminology. Calling it a dimension seems to bring into people's minds special relativity or Minkowski's ideas and so on.
Or geometry.
You know, if you have the three-dimensional nabla operator, the Laplacian, the squared equals zero. Well, if you generalize it to the quad, I'm talking mathematically now, the quad squared equals zero. Well, then you have the three parameters, the ordinary spatial parameters, plus this ICT parameter, and it works out perfectly. So maybe calling it a dimension is causing the problems. I don't know. That may be helpful.
That's been a problem since general relativity was invented in cosmology. So, you know, that shouldn't really be a problem. I mean, it's been in the scientific literature now for at least 100 years, I think.
Well, if a dimension isn't height, depth, and width, what is a dimension?
It's a
And
mathematical
you're
definition.
Let me
Well, how
answer
do
you.
I mean, math applies to reality, though, or it should clearly, present what the reality is. So I don't understand what a dimension is.
The reality is the three-dimensional observable world in which we exist.
Yeah,
Another way of
let me
looking
answer
at it
the
is
question,
the
Ian.
distance between 2 points. You know, you have the Pythagorean in 2 dimensions, it's x squared plus y squared, the square root of that. In 3 dimensions, x squared plus y squared plus z squared, square root of that. Well, if that equals, say, c squared t squared, which is the distance that say, a light ray will go in the particular time, you just get x1 squared plus x2 squared plus x3 squared plus x4 squared, square root of that. X4 is equal to ICT.
Let me answer your question because Ian, please, Jerry, stop your questioning. I want to answer Ian. First of all, in classical physics, we don't need any equations with 4 spatial dimensions. We don't need it. Ni ICT, ni CT. In our observable 3-dimensional world, it's not universe, world, we can use our standard physical laws, what we have right now, written in 3-dimensional equations. No 4th dimension. I told you, 4th dimension, we have only as a result of the 4th dimension, we have that all these parameters must be time varying. That's it. The conclusion for 4th dimension is only parameter q. All of them depend on q, means they depend on time. How come in 3-dimensional time you use the same equations, Newton's, Maxwell, whatever, 3-dimensional. There is no Lorentz, there is no 4-dimensional equations. Forget about them. There are standard 3-dimensional equations with time varying parameters. We calculated them before as constant. We calculated all our equations based on constant, and you must take into account, consider time varying from cosmological time, not even from solar time, from anything else. We live with you in solar time, but there is no, in cosmology, there is no solar time. Cosmology cannot know about the sun when it will be it will appear 4.6 billion light years ago. Yes, that's why very important to understand, guys. I've done the calculation as standard plasma physics, Maxwell equations, and all this stuff in 3-dimensional space, 3-dimensional equation. You don't need to put any extra. No, you don't need it. What you need only to have in mind that all these constants which we talked with you about before, now they are time varying, and time is a cosmological time from the very beginning of our world, 14.22 billion years ago. That's why you don't need to do anything with classical physics. Stay as it is. But Dirac in 1937 told gravitational constant is not constant, it's time dependent. He was absolutely right. That's it, what we really need to do. Time varying parameters, that's it. And time varying parameters, this is a witness of existence of the fourth dimension. There is no other choice to explain it.
I have a question regarding the cosmic medium. Yeah, I mean, there are many different ether theories. I don't know for sure if you consider the cosmic medium an ether theory. However, though, I've heard that the ether could consist of minuscule particles that travel into all directions, which I mean, that sounds sort of out there to me, though maybe it's the truth. However, though, if the cosmic medium consists of protons, electrons, photons, and so forth, why wouldn't these particles blend in with the rest of such particles in the universe?
Why? I misunderstood the question. I'm very sorry. Please repeat one more time. Why?
Well, you stated that the cosmic medium consists of protons, electrons, photons, and
Yes.
so forth. Why wouldn't because these particles exist within the universe as part of the universe, why wouldn't they blend in with everything else?
Indeed, I don't. Let me tell you, even our standard, ordinary particles, protons, electrons, it's the result of self-annihilation of universe-created particles. The most energetic particle has a rest energy 1.3 tera electron volts. As a result of self-annihilation of these two particles, you can create all table of chemical elements what we have right now, because energy-wise it's so much against protons and all the other particles of our standard ordinary particles of three-dimensional observable world. Observable world is three-dimensional, guys.
As far as the cosmic medium goes, um, is it meant to propagate gravity and light, or something more, or something else?
First of all, there is no propagation of gravity. Gravity, according to Lesage, it's a difference in pressure between two big masses. You have less pressure inside, and outside you have more. And you have some attraction, not attraction. It's a result of difference in pressure from one side to another side. And they are going together towards each other because of a difference of pressure. That's it. There is no gravitational interaction. There is only change on pressure on both sides of these macro objects.
Yeah. I have heard some ether theories express something similar as far as what creates the action at a distance effect. So,
Let me talk with you about ether. Ether, I don't know what does it mean. If you can give me the definition, I will be more than happy. In my cosmic medium, there is a definition. All of these particles that saturated my medium, cosmic medium. What does it mean, ether? I don't know. Many times they talk, it's like a perfect liquid. What kind of liquid we can talk about? If the density of it 10 to the minus 24 times less than the density of air around us. I told you, in a cosmic medium, concentration of protons, one of them for 4 cubic meter. What kind of fluids you can talk with such a concentration? Guys, tell me, okay, answer my question. What is your ether in your mind? What do you mean when you're talking about ether?
I don't personally subscribe to the ether, though I accept it has a possibility, though I'm skeptical. Though Michelson and Morley originally thought that the ether was a medium or substance which permeated the whole universe, which was only for the propagation of light. It was later that they introduced gravity. Maybe it was before, but that was Michelson and Morley's primary purpose with the interferometer, with which they didn't detect it allegedly, but however that goes. But there's also the idea that the ether isn't fixed and stationary, that it flows around and that's somewhat malleable. And I don't really know if the ether collects around, like some theories might, the ether might somewhat collect around celestial objects and less dense in outer space. I mean, I'm just listing a few examples. I don't personally subscribe to the ether per se.
You didn't give me the definition of ether. I misunderstood you.
Well,
Tell
that's
me,
the
what does
point.
it mean,
There's
ether?
quite a few.
Okay, give me at least one. What do you mean ether when you're talking about ether?
A
What
a
ether?
universal medium that propagates light and maybe gravity or maybe all physical phenomenon. See, there are different versions of it. Your version of the cosmic medium sounds similar to me to an ether. I mean, like
You misunderstood my
maybe it's
talk.
just
It's
semantics.
not. It is not. It's misleading you. My cosmic medium consists of all these particles. I insisted, all of them massive, all of them particles. Let me give you the analogy. Many times I told you, we have air around. It's a medium. Yes, it's a medium. We have our sound going in this medium, but this medium consists of particles, oxygen, nitrogen, hydrogen, whatever. There are particles. You cannot name ether medium only. Please saturate your medium ether with something. Tell me what is something in your
Well,
medium.
the air can be a medium, so can water as far as propagating sound, for
Uh,
instance. I mean, sound requires a physical medium. They thought that light, while very different than sound, would require some type of universal medium in order to propagate in empty space. Well, they say it wasn't empty, the ether is there instead. I
what
think
does
empty
it mean,
space is
ether?
inevitable
Oh
and that
my
everything
God.
fills empty space, even
All
the
right,
ether.
let me sort of
It's,
interrupt here a
it's
little
all
bit.
right. It's enough.
Let me interrupt and answer the question that you're asking, Vladimir. This ether idea is held on to by people because they say that if you light is a wave and a wave requires a medium. Okay, let me repeat that. Light is a wave, electromagnetic waves are waves, and waves require a medium in order to exist. So therefore, there must be an ether. That's the syllogism that people who believe in ether, that's their argument. Does that help you any?
No, I will tell you why. Because medium ether, the same unknown entity. What does it mean? I have air around. I can saturate it with particles. I know it exists and I
Well,
know what is the component of it.
protons, electrons, and
It's
photons
a
are particles,
medium.
though.
Huh?
The protons, electrons, and photons. I mean, how is that a medium, though? What is its purpose? Does it propagate something?
So what he's saying is that your cosmic medium, as I think so. He's saying that that doesn't propagate light waves, so therefore it's not a medium.
Unfortunately, he is absolutely wrong because there are protons and electrons. There is some interaction between photons inside of this cosmic medium. As a result, we have a black body radiation.
Oh, yeah. I'm just actually closing down something that I've just taken the video away. Just take the audio.
Unbelievable.
Okay, I think that's pretty clear. I think I understand what you're saying, Vladimir, and you're saying that your cosmic medium is capable of propagating light, but the propagation mechanism might not be what people believe is the mechanism.
Well, also, how to distinguish just free protons, electrons, and photons in empty space? How to distinguish them from the cosmic medium, which consists of the same?
I'm not sure what you need to do that. Okay, we're coming up here. Yeah, 4 minutes. All right. Maybe you can try to answer that, Vladimir.
I think he's frozen.
Okay, that's not good. Yeah, now he's gone.
Oh,
All right, so I'm going to try to sort of,
Good, at least.
ask Vladimir to summarize, and and my kind of view on this is that um, what the most important, the thing that's kind of important and connects back to what we had in the presentation yesterday is this idea of the Dirac introduced, Paul Dirac, that that these constants, gravity and these other things which are called constants aren't really constant and they change over time. And that's kind of the root concept that's behind what Vladimir is saying. And that leads to the so-called gravitational constant not being a constant. And so what Vladimir has a model that it's a mathematical construct. So let's call it a mathematical construct so we don't get into these philosophical issues about why isn't it 5 dimensions. It's a 4-dimensional mathematical construct, okay, that is been created that facilitates a mathematical way to calculate these changes in the constants, the gravitational constants, and these other parameters. So the 4-dimensional model facilitates a way to do the calculations that he has done. And that's why it's a 4-dimensional hypersphere, because it allows these calculations to be performed. Did I say that fairly correctly, Vladimir?
Yes. I want to answer the question about the ether and this wave propagation.
Well, we don't have much time.
It will take a couple minutes.
Well, we don't have.
First of all, our standard ether, guys, standard ether can produce and can support only longitudinal waves. Longitudinal. In our standard medium, we have only longitudinal waves. And everybody knows that electromagnetic waves, they have 2 different polarizations. How to take care about it? Nobody took care except Mark Kulag. In 1848, it was a genius, guys, genius mathematics and so on and so on. He took a look on this ether. He saturated this ether with a principally different potential energy, depending on rotation only, not on compression or sharing. It's a rotational potential energy. And what is important, based on this theory of him, he showed, first of all, that you can, in this ether, so in accordance with his idea, with rotation.
It's gonna cut off here. Okay, appreciate everybody participating. Thank you, Vladimir, and we can discuss this further. All right.
Thank you so much, guys, for good questions. You know, it's very difficult to take, but please try to understand what I'm talking about. And even this, Mark Kulak, he developed even